So today I'm going to continue the series of COVID-19 videos shot from my home. And what I want to talk a little bit about is the difference between decimal and binary notation for numbers. Okay, so I want to just do a sort of compare and contrast. How does decimal notation work? It's the one that we use regularly and that we're all sort of tacitly familiar with. And once we understand the ins and outs of how it works, we really just have to change one thing to get at the binary system. So in the decimal system, I can write down a number like 5,329, right? And what that means is I'm dividing this, this number is being expressed with four numbers, something in the ones column, something in the tens column, something in the hundreds column, and something in the thousands column. And I can rewrite this as 1, 10, 10 squared, 10 cubed. If I really want, I can write 1 as 10 to the 0 and 10 as 10 to the 1, and then we get a nice pattern. 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. But all that really means is the ones column, the tens column, the hundreds column, the thousands column. And so what these numbers are telling me is how many ones are there? 9 ones. How many tens are there? 2 tens. How many hundreds are there? 3 100s. And how many 1000s are there? 5 1000s. And if I add up 5,000 plus 300 plus 20 plus 9, I get this number. And it's being represented in terms of how many different powers of 10 there are. And notice that I never have a number like, I don't say there's going to, I never say 12 tens or 33 100s. I always keep the numbers between 0 and 9 because instead of saying 12 tens, I would make that 1 100 and 2 tens. Right? Because 12 tens is 120. So the decimal system only needs you to use the numbers 0 through 9 in each column, and you add up the corresponding number of powers of 10. The binary system works exactly the same way. The only difference is that instead of being base 10, powers of 10, it's base 2, so it's powers of 2. So if I write down a number in binary, instead of using the digits 0 through 9, right, I use the digits 0 through 1. I don't go past the number 2, just like in the decimal system, I don't go past the number 10. So a number in binary might look like this: 1 0 1 1 0 1. Right? For example, it's just a random number in binary that I happen to write down. And it works the same as decimal works. This is the ones column. This here, it's the next, it's instead of being the tens column, this is the twos column. This here is the fours column. This is the eights column. This is the 16s column. And this is the 32s column. And that corresponds to the powers of 2. This is 2 to the power of 0. This is 2 to the power of 1. 2 to the 2. 2 to the 3. 2 to the 4. 2 to the 5. And if I had more digits going up here, I would have higher powers of 2. Just like if I had more digits over here, I would have higher powers of 10. 10,000, 100,000, a million, and so on. And so just like I did on the decimal side, I can translate this number in binary into a sum of powers of 2, rather than a sum of powers of 10. So this says there's 1 1, so I get 1 1. There are 0 2s. There's 1 4. There's 1 8. There are no 16s, and there's 132. So 132, no 16s, 1 8, 1 4, no 2s, 1 1. And if I add that up, what I'm getting is, now I'm writing these numbers here in decimal because that's the most familiar one. 32 plus 8 plus 4 plus 1, right? 32 plus 8 plus 4 plus 1, which is equal to 45. So this sequence of digits in binary is a representation of the same number that this sequence of digits is a representation of in decimal.